to attempt to display that to the user as quickly as possible. But I know in my JavaScript code here that it doesn't really make sense to display this element until I have the title, body, and footer together. So I can batch these. And once I batch them together, I can update that inner HTML just once with the resulting contents. I end up with just one inner HTML reference and one visual update, saving a significant amount of time inside the browser. So very quickly in the past 30 minutes, we've gone through the 20 best practices to improve performance. So a quick test. How many of you can name those 20 best practices? All right, I have to go through them really quickly before we transition to the second part of today's presentation. So the first best practice is to compress file downloads. Use conditional requests. Provide cacheable content. Minify your JavaScript. Don't scale images. Use image sprites. Link JavaScript at the bottom of the page. Add a defer tag to JavaScript when you must link it at the top of the page. Link style sheets at the bottom of your page. Avoid using the add import. Minimize walking up that lookup chain. Cache function pointers. Use the native JSON object or native objects whenever possible over other implementations. Remove duplicate scripts. Minimize your number of DOM interactions. Use the most efficient DOM APIs for any DOM access. Use query selector all for groups of data. Only send required styles. Simplify selectors. And minimize page layouts. Now, I wanted to come back to the chart that we looked at earlier, the subsystem distribution across these top 5 sites. And I wanted to call out a couple of things. The first is that site number 1 didn't follow many of the best practices that we talked about for JavaScript. They bring down a whole bunch of JavaScript, which is never executed. It can never even possibly be used in the page. Site number 2 doesn't follow the best practices that we talked about for the DOM or for marshalling itself. They actually cross that marshalling tier a lot, and that really increases the time it takes to load the page. Now, one interesting point here, if you remember from our initial data, is that site number 2 had the smallest amount of JavaScript of all of these pages. They also weren't using any JavaScript frameworks. They had written all their JavaScript by hand, trying to make it as fast as possible. But in doing so, they actually didn't improve the performance of their site. Site number 3 does a fantastic job of caching content. They follow the best practices for every single item on their page. Site number 5 spends a lot of time in the DOM. Every time they need something from the DOM, they cross that boundary and they access it from the DOM itself, and then they often walk the DOM. Site number 4, honestly, site number 4 doesn't really follow any of the best practices that we talked about today, and that's why site number 4 was the slowest to load. Great. So I'm happy to take questions on best practices at the end of the presentation, but I'd like to move into section number 2, which is a preview of Internet Explorer 9 performance. I'm extremely excited to show you guys what we're doing at a deeper level than we covered in the keynote earlier this morning. For those of you who were in the keynote this morning, we talked about hardware-accelerated HTML5. And hardware-accelerated HTML5, and as we took a step back and we thought about what the types of applications that HTML5 would enable, we believed that we needed to re-architect 2 of the subsystems that we just talked about. The first being the core JavaScript engine inside of Internet Explorer. The second being the rendering piece. If you remember back to the display and rendering charts that we looked at, there's a lot of time spent in rendering. And what we've done is we've brought compiled JavaScript to Internet Explorer 9. We've also brought GPU-powered HTML5 graphics. I'm going to show you what these 2 things mean next. And I'm going to do that with a demo. So for those of you who were in the keynote this morning, I'm sure that you saw the flying images demo. I'm running Internet Explorer 8 here, and you'll see that as I move my mouse, I have some images that are trying to follow the mouse. And you'll see that they're moving at about 4, 5, 6 frames a second. And they're having a hard time following me. Now, if I had a CPU meter here, you'd also see that my CPU is completely pegged. It is, the browser is moving these images as quickly as it can. I'm going to go ahead and close Internet Explorer 8, and I'm going to look at Chrome, the same demo. And you'll see that in Chrome, the images are moving at 2 or 3 frames a second, and they're also having a difficult time following my mouse. I'll go ahead and close that. We'll take a look at Firefox. Firefox is much more responsive. It does a much better job, although sometimes it has, there it goes. It can be a little chunky. And when I increase the number of images, you can see that I quickly drop down to about 10 frames a second, 8 frames a second. And it has a more difficult time following my mouse. I'm going to go ahead and skip Safari now for brevity's sake. And I'm going to go to the Internet Explorer 9 platform preview, which during the keynote today you saw we announced, which is the first preview of Internet Explorer 9. And I'm going to look at that same demo, and you'll see it's incredibly responsive. And I'm running at 64 frames a second. I can speed it up. And you'll see that even going faster, I'm still at 64 frames a second. We can zoom in. Zoomed in, still 64 frames a second. We can speed it up while zoomed in, and we're still well above 60 frames a second. Now, your monitor can only display 60 frames a second. And so this 64, 65 number is as fast as your monitor can display this to you as a user. And in fact, this is too easy for us. Let's zoom in a little bit. Let's add some images. We're up to 144 images, still at 61, 64 frames a second. I'm going to go ahead and speed up. This is what we mean by hardware-accelerated HTML5. And this is what compiled JavaScript and GPU-powered graphics enable. I'm going to jump back to the slide deck and talk about this architecture a little bit more about what we've done. I'm going to start with GPU-powered HTML5. Now, when I often say GPU, a lot of you think of hardcore games. Many of you might be gamers or have these really high-end GPUs inside of your machines at home with cooling fans and heat sinks. But everyone has a GPU. Over the past 8 years, every Windows machine has shipped with a GPU on board. And when we were planning the Internet Explorer 9 release, we went and did some research and found that from the Windows Experience Index results, everyone has a pretty decent GPU. You'll see that there's almost all of the GPUs out there score at least a 4 on the index results. The machine I'm using for these demos is actually a 4.5. So this is on the lower end of all GPUs that are out there today. On the left here, you'll see kind of a multi-core CPU. In this case, it's a quad-core. And CPUs are really general-purpose processors. The graphics today inside of all browsers are done on the CPU itself. But when we were looking at HTML5 applications and the types of applications that we expected developers to build, we really wanted to give them full access to the GPU, which on the right here, you'll see a GPU. A GPU is made up of lots of really small, highly specialized silicon processors designed for graphics. There's shaders, there's subsystems designed for alpha blending. And with Internet Explorer 9, we've re-architected our display subsystem to be built on top of the GPU, so that all of the web applications that you build are no longer rendering on these general-purpose CPUs, but are now being rendered on the GPU itself. That's what enables these incredible graphical experiences like you just saw. The second thing that second large architectural